What if the key to building true AGI isn't buried in more code or bigger data sets, but in the grammar of an ancient language? It's a pretty wild idea, right? But there's a compelling new argument out there that suggests just that, and we are going to dive deep into it. Let's get started. So, if you've spent any real time with large language models, you've seen this happen. You ask for a simple fact, and what you get back is beautifully written, totally confident, and completely wrong. We call it hallucination. And it's not just some funny little quirk. It points to a deep structural problem with how these AIs are built from the ground up. Okay, so here's our game plan. First, we'll nail down exactly what this reality problem is. Then we'll get into the really interesting part, this ancient linguistic blueprint that's being proposed. We'll break down how its logic works, make it clear what the goal here really is, and then wrap up by thinking about what it all means for the future. All right, first up. The biggest hurdle for today's AI isn't really about needing more data or faster chips. No, the real issue is much more fundamental. It's about how these systems even understand what words mean in the first place. Think of it like this. LLMs are incredible mimics. They've read basically the entire internet, so they're amazing at predicting which word should probably come next in a sentence. They get the context. But they don't have an internal logical system for what a word actually means. And that's not something you can just fix with more data. It's a flaw in the architecture itself. So when we talk about a hallucination, what's really happening on a technical level? Well, it's a breakdown. It's a disconnect between three things. The symbol, which is just the word itself, the concept, which is the idea it represents, and the referent, the actual thing out there in the real world. When those three drift apart, the AI can still string words together, but it has no idea what it's truly talking about. And that brings us to this really radical idea. What if we've been looking in the wrong place for a solution? What if instead of just more computation, we need a better model for language itself? A model we could borrow from a human language that has a totally different kind of internal logic. So, this is the hypothesis we're digging into. The idea is that to get to true artificial general intelligence, we might need to build systems that don't just learn from external data, but that have their own built-in self-validating rules for creating meaning. Now, we have to be absolutely clear on this next point. The reason the source material zeroes in on Arabic has nothing to do with culture or thinking one language is better than another. Not at all. It's being treated as a formal case study, a structural laboratory, if you will. Why? Because its system for building words is so incredibly regular and logical, it makes it a perfect model to analyze formally. So how does this actually work? What does this logic look like? Well, it all boils down to the way the language creates words through something called derivational morphology. That's the engine driving this whole thing. In English, the word water doesn't have any logical connection to the word drink. The relationship is arbitrary, but in Arabic, meaning is built systematically. It starts with a three-consonant root that holds a core concept. Then, by plugging that root into predictable patterns, you can generate a whole family of related words, and you know exactly how their meanings are connected. This is a really brilliant analogy from the source material, especially for those of us with a tech background. Think of the root, like KTB for writing, as an abstract class in programming. It sets the whole semantic field. Then the pattern you apply is like a generative function. It tells you what kind of thing you're making. You put them together, and bam, you get a concrete semantic object. Kitab, a book. The meaning is literally constructed, not just guessed from context. And when you put the two approaches side by side, the difference is just stark. Our current statistical models, they're totally dependent on external context, which makes them fragile and prone to those hallucinations we talked about. But a structural model, it has internal coherence. It can check its own work, in a way. That gives it a kind of foundational stability that current systems just can't match. Okay, let's just pause here for a second, because this next point is absolutely crucial. We need to be really clear about what the end goal is here. This is not about trying to make an AI that speaks Arabic. And the source puts it perfectly right here. The goal isn't to teach an AI a specific human language. It's to take the logic, that systematic, regulated way of generating meaning, and use it as the blueprint for the AI's own internal language of thought. It's about borrowing the architecture, not the vocabulary. So this all leads us to the big finish. What would this kind of structured intelligence actually look like? What does this new path forward mean for the future of AI? What we're talking about, really, is a potential paradigm shift for the whole field. It's about moving away from models that just find statistical patterns in data and moving toward models that have an actual formal structure for understanding. It's the difference between imitation and genuine comprehension.
So, an AGI built on this kind of logic would be a whole different beast. Its thinking would be regulated and predictable. It would have its own built in tools for checking if what it's saying makes sense. And this is the big one, it would finally have a systematic way to connect the words it uses to the concepts they represent, solving the hallucination problem right at its root.
And that leaves us with this final thought to chew on. We take for granted that our own human intelligence is deeply shaped by the languages we speak. So the critical question for the future of AI might not be if language will shape it, but rather what kind of linguistic logic we decide to build it on. And that question, well, that takes us way beyond just engineering and deep into the heart of logic and linguistics itself.